All right, number 47. It says in 2012, population of a city, is 6.16 million. Exponential growth rate was 3.26 per year. It says it's an exponential growth rate. Find the exponential growth function. So on my formula list here, I've got this little guy. P of t equals P sub 0, or P naught, e to the kt. This is my growth function. And the P naught, that's your original population. The E is just E, right? You keep the E. K is your rate, and T stands for time. This is population, a function of population as a function of time, P of T. So, knowing that just from the formula sheet, find the exponential growth function. Population given time, that would be 6.16 E, and my percentage is 3.26 per year. I'm going to convert that to a decimal, 0.03. You move the decimal place 2 spots, 26, and then T is time. Now my answers that I get out of this will be in millions, so the answer is in millions. So if I plug a value in and I get just 5, or say I get an answer of 7.3, that is 7.3 million people. Right? And I'm just that you don't have to write that down on your answer, but I just want you to make sure you understand what you're doing here. Since this is in millions, your answer will be in millions, whatever that value is right there. Part B, find the population of the city in 2018, rather than the nearest whole number. So in 2018 versus 2012, that'd be what, 6 years? So let's find P of 6 then. And you'll need a calculator for this, I suppose. I know I do. I figured it. If I do, you do. Who knows? You might not need it. I don't know. Yeah, I know it's low. Come on. Alright, let's delete everything. We want 6.16 E to the power of 0.0326 times 6. 7.49 million. And it wants to round to the nearest whole number. The nearest whole number, that rounds. In my opinion, that would round to this, to 7.5. I don't want to round that all the way down or all the way up. I want to. I mean, if you're looking at the nearest whole number, you look at this number and say, well, it rounds down. But, man. Okay. Okay. Part C. I don't quite agree with that, but I'm going to put both of those answers down on my paper here. That way everyone understands. When will the population be 10 million? So when is the output 10 million? So here we have to solve for t. Now, since we want to try to solve for t, we need to try to get, we're going to utilize logarithms to get the t out of the power. Okay, so I'm going to get rid of the 6.6 first. I got to get rid of it. I can't have anything in front of e, because I'm going to use the natural log to get rid of it, but I can't have anything in front of it. So I'm going to leave that as 10 divided by 6.16. I'm not going to simplify that at all. I'll put it all in my calculator at once. Okay, now if I take the natural log of both sides, or convert it into a logarithmic equation, depends on how you look at it. Well, and then since this is a logarithm, I can move this to the front. Times natural log of e. Now, natural log of e is 1, so I can cancel this to 1, and anything times 1 is itself, so I don't have to leave anything there. So now we're left with this thing right here. Now this is just a number, natural log of 10 over 6.16, and you've got t here by itself as being multiplied, so to undo that we divide. So we're going to divide that by 0.0326. That will give me my time. That will give me my time. So natural log of 10 divided by 6.16. I'm going to divide that by 0.0326. 14.86. And it says to round. It doesn't say where to round. When will the population be? Well, 14.86 years. The population will be 10 million. Cool. Find the doubling time. When will your population double? So, we know what we started with. We started with 6.16. So the doubles of that would be 12.32. So we're going to do this all over again, except when instead of it asking for 10 million, it's asking for 12.32. Now, here's going to be something interesting. I'm going to solve it the same way. I'm going to divide that out. Now, I know what this is because I just multiplied 6.16 times 2 to get that value, right? I just multiplied. That number is going to be 2. 12.32 divided by 6.16 is 2, right? Now, think about that for a second. When I take that value and double it to get this one, and then divide by it a second ago, that number is always going to be 2. It'll always be 2. So if you get any kind of question where it asks about doubling time, you actually don't even need to know what the starting population or the starting value was, because you're always going to divide it out, and it's always going to be doubled. So this value is always going to be 2. E is always what E is. Or this value right here is going to be your rate in time. So the only thing you need to know about a doubling time is your rate. So that's fun. We take the natural log of both sides, or rewrite it as a logarithmic equation. The property says if I have a logarithm, I can take that power and put it to the front. Now natural log of e cancels to 1, and 1 times anything is itself. And then we're just going to divide that away because I'm multiplying by t. So here's the thing. If you want to know a doubling time, really all you need to know is natural log of 2 divided by your rate, and that will tell you your time. That right there, your rate will tell you your time, or k. They say k on the formula sheet, but that's essentially your formula for your doubling time, because like we said a second ago, that'll always be a 2. You're always going to have a rate here, and then you're always going to take the natural log, blah, blah, blah. So what is the natural log of 2? Divide that by 0.0326. 21.26. It's going to take 21.26 years for the population to double.